to look at a series and parallel circuit calculation. Pause the video now and try all parts of this question. Part I says compare the potential difference across and the currents in X and Y. So we obviously know that potential difference is the work done per charge, the energy transferred per charge, and we know that the current is the rate of flow of charge. So how is that going to compare in X and Y? Well, we know that X has a greater resistance than Y. We're told that in the question, which means that the potential difference, or the PD across X, will be greater than Y because it has a higher resistance. What about the current? Well, we have a series circuit. It even tells us it's a series circuit. So we know that current is the same everywhere in a series circuit. So it will be exactly the same in X, or through X, and through Y. What about II? Now the resistors are in parallel with the cell. So again, we compare the potential difference across and the currents in X and Y. So the potential difference, the work done per charge, the energy transferred per charge. So if you're an electron, you can either go this way or you can go the other way. You could go through X. You can't go both ways at the same time. You can only go one way, which means that the energy that you have is going to be transferred either to Y or to X, which means the potential difference, which is the energy transferred per charge, is the same across X and Y. What about the currents? Well, we know that X has a greater resistance than Y, which means now that the electrons have a choice, they can either go this way or they can go this way. Where are they more likely to go? They're always going to go the path that has the easiest resistance, or more of them are going to go the path that has the easiest resistance. So we would say more electrons, which means a greater current, passes through Y as it has a lower resistance. The lower the resistance, the more current we will get if they are in parallel. Part B, it says calculate the total resistance of the 4 ohm and 12 ohm resistors in parallel. Now in AQA, you don't need to use the resistance in parallel formula. If you want to know what it is this, but we're not going to bother actually calculating it, because what you need to know is that the total resistance in parallel is always less than the smallest resistor. So it's always going to be less than 4 ohms. So D is the correct answer. Calculate the current. Well, this we can do. So we know there's 0.4 amps in this part, and then we know it's going to split. Some current's going to go that way, some current is going to go that way. And we've got a 4 to 12 ratio, or 1 to 3. So we know that the current will split in the ratio 1 to 3, and we know that more current will go through the path with less resistance. So in the 4 ohm resistor, we're going to get 1 out of 4 parts in total, and actually the numbers are really easy here. It will be slight mistake. This gets more of the current, so it's going to get 3 out of 4. So it's going to get 0.3 amps, and the 12 ohm one gets less current, we get 0.1 amps. It's just a ratio problem, but recognizing that more current goes through the path of the least resistance. How do we calculate the potential difference across the cell? Well, there's a couple of steps to this. We need to know the potential difference across the first branch, and then the potential difference across the second resistor here, and then we can add them together. So across the first branch, we can work it out. We know that potential difference is current times resistance. So the current, well, we could pick either of these two paths. It doesn't matter. The potential difference across both of these will be the same, just like we said over here. So I'm going to pick the top one. So 0.3 amps times by 4 ohms, which is going to be, could do this in my head, I guess, 1.2 volts, and then that's V1. V2 is, well, 6 ohms times by the total current going through this one, which is obviously these two currents added together, which is this current here. So 0.4 amps times by 6 ohms, which is 2.4 volts. And then the total V equals V1 plus V2. So add these two together, you get 3.6 volts. And then it says, James predicts if the 3 resistors in the circuit had been connected in series, the current in the circuit will be less than 0.4 amps. Explain whether his prediction is correct. So if they were in series, what would happen to the total resistance? Well, the total resistance will increase, all right, because we know that resistors in parallel, the total resistance is always less than the smallest resistor, which means the current will decrease. So if we want to explain that with the help of a formula, we could use this formula here. The voltage is constant. The potential difference from the battery is constant because it's the same battery. So if you make the resistance go up, then the current must go down.